20, 15 minutes?
Yeah, I think it's 20, 30. It really depends, like what are the topics we're going to stop, maybe like a bit longer, and then we are, seeing how much it's going to take actually.
So you don't really have like a hard limit or a deadline or anything like that?
Yeah, let's just try to kind of keep it in the 30 minutes. I think it's like really optimal kind of time
Okay.
for us.
Like I said, this is my first time with doing something like this, so feel free to lead me somewhere.
Yeah, definitely. I will do that. So if we know if we're recording, then it's super great because then I can kind of have this.
It does save live at the top, so I'm assuming it's recording.
Excellent. So good morning, all the listeners and viewers here, and we're
Hello.
Yeah, hi Piotr. We are super happy to host this Revolci expert session today, where we're discussing how you can run your Microsoft workloads on Google Cloud Platform. My name is Christian. I'm the Nordic Regional Manager for cloud company Revolci, who has been actively in the IT business for 25 years, and almost for a decade we have been a Google Cloud reseller and Google Cloud partner. And today we're having Piotr here. So hello, Piotr. Maybe you can give like a short introduction about yourself.
Oh, so hello everyone, and thanks for having me, Christian. So my name is Piotr, obviously. Marczyszyn, I know it's a hard one, don't try to pronounce it. I'm the Director of Engineering at Minto, and I've been doing this for close to 5 years now. And in general, I've been working with building, designing, developing large-scale distributed internet systems for almost 15 years now. And well, I have some things I would like to share with you guys, and hopefully you'll find it interesting.
Yeah, definitely, and thank you, Piotr, for that short intro. Because what this webinar is all about is actually to kind of dig deeper into your customer success and into your best practices. How did you went to GCP from Microsoft, and everybody who are listening and are viewing this session, we try to kind of go through all the frequently asked questions before you're planning to go for GCP. And if you have any questions meanwhile we're discussing, feel free to if you're watching us on YouTube on the right side, and if you're watching us on the LinkedIn down below. But maybe to kind of give like a head start, we just discuss what's the Minto about, what's the company doing on an everyday basis.
Okay, so a few facts about Minto then. In general, we work with the fashion industry, and what we do and what our mission is to find a way to connect local boutiques of various sizes. I mean, you can be a small boutique, a medium-sized boutique, or a very large brand. It doesn't really matter for us. We will take care of you the best way we can. And we try to connect you with all the customers you could ever want all across, for now, Europe, hopefully eventually all around the world. Right now, we're active in 13 different European markets. You can see those on the right on the presentation. And we have about 1.5, a bit above that, active unique products available, with over 10 million actual items that are unique and also available. The entire Minto family is comprised of more than 450 people at the moment, and we're growing very, very quickly. And right now, we're working with over 1,100 partners. So that's Minto in a few words, in a few numbers as well in general. When it comes to tech at Minto, we've got over 60 services with almost 40 people working on them in various roles. That's engineers, developers, QA specialists, product owners, and so on and so on. And again, just like the rest of the company, we're growing very quickly, and we're looking to hire even more talent to join us and help us out. Currently, we've got 7 teams, hoping to scale that up soon as well. And in terms of infrastructural resources we are using right now, almost 1,500 virtual CPUs running on average on every second. That's actually a stat taken from the GCP panel. And almost 4,000 gigabytes of RAM on average every second. It varies, obviously, because we scale up, we scale down. Some environments go up, they go down as they are needed, not needed. But on average, this is the output from the previous month. So we're very proud of the size we've accomplished, but we hope to get way, way bigger soon.
Yeah, these are impressive numbers, Piotr. So maybe just to elaborate here is to dig deeper into the main topic we want to discuss and understand like what are the actual technologies, what Microsoft technologies Minto is using right now.
So what you need to understand in general is that we are not a Microsoft-only company. We're actually running a hybrid ecosystem. We have solutions from multiple technologies because we choose our tools for the problem at hand, basically. So we've got some Microsoft solutions, we've got some open source solutions based on different approaches. You can see that on the screen right now. And what we're using in terms of Microsoft is actually obviously Windows Server. You can't really go without that. IIS, and we've got a few services running .NET Code. And interestingly enough, some of it runs on the classical setup behind the IIS on a Windows Server, while some of it uses .NET Core approach and is hosted on Linux. And that's the technologies in general, but for data, we actually use Microsoft SQL Server and Power BI. Minto's entire analytical setup for the moment is actually based on Power BI and on Microsoft technologies alone. But aside from that, we've got other technologies, like I said, more open source. And the funny thing we've noticed is that when it comes to running Microsoft, we tend to build fewer VMs, but they are larger in general. They have more resources assigned to them. While when we're working with other technologies, we tend to build smaller VMs, but more of them. And as it turns out, it's something that we figured out very recently. It's a difference, but it's a kind of a convenience thing. We don't really care how many VMs we have in terms of infrastructural maintenance because we use automation for that. But I'm sure we'll discuss this more in a moment.
Yeah, definitely. And maybe the key question here is why did you decide to go for a GCP and switch your Microsoft services to GCP and run it all of that on the Google Cloud?
Oh, we actually didn't. I mean, what I'm saying is we had Microsoft, so the same ecosystem we have right now, we actually had before we migrated to GCP, and we never really tried to remove it, and we're not switching away from Microsoft to GCP. We just move everything we have with Microsoft to GCP. What we were looking for is a cloud solution that could let us remain a hybrid company. We want to keep a few of our Microsoft solutions. We want to expand on our open source ones as well. And we've chosen GCP for a number of reasons in general when it comes to technology. But when it comes to Microsoft specifically, we wanted to make sure that we can have a single virtualization technology. That's GCP in very basic terms, where we could combine everything we've got seamlessly. So what we've discovered through our research and through our 1.5 years of experience with GCP right now is that it doesn't really matter if you're running open source or Microsoft. If you're doing it on GCP, it will work well, and you can combine it well. So if you're a fully Microsoft company, you can definitely go with GCP. If you're a hybrid company like we are, you can definitely go with GCP as well and have just one place where everything is hosted and everything works really, really well.
Okay, that's interesting to know, because most of the people think that it might be not possible, and if you cover it like this, it's great to kind of understand also the reasons why you did it, because as I understand, the Microsoft were used in the very beginning, or what was the reason that you started with Microsoft and then switched to GCP, and what was the kind of the pain point that you were hustling with to kind of go for that shift?
Okay, so again, we didn't really start off with Microsoft. We started off as a hybrid straight away. We've had both open technologies and Microsoft technologies. And this was because it's easier to find talent when you have a wider scope of technologies available at your hand. So we had open source technology teams, we had Microsoft teams, and different solutions were built based on what the technology would be used for. And we started off first with, like most companies, with bare metal infrastructure, so just physical hardware. Then we tried moving to virtualization using VMware, and then to a private cloud solution. And combining all of that, well, it worked, but the amount of work we had to put into it every single day in terms of maintenance, expanding, keeping it up to date was just massive. And we wanted to get to a single point where everything is virtualized in the same way. And we couldn't actually do this without a public cloud like GCP, because when it comes to Microsoft, we had issues with licensing. So it wasn't that easy to acquire licenses. It took time. It took days, at the very least, weeks sometimes, to properly respond to what we needed. And let's say we have an SQL server that we want to scale very quickly or add a new one. Then you have to go through the process of buying the license, procuring it, and so on and so on, setting it up, getting the hardware, all of the usual hurdles you have when you're using physical hardware. And then we discovered GCP, where you don't have to bring your own license. It's actually, that's what the model is called, bring your own license. And we don't want that. We don't have the connection with Microsoft that allows us to bring our own licensing at the right price and at the right speed. GCP does that for us. So hosting the rest was easy. Hosting Microsoft with the licensing provided by GCP was also easy. That's why we chose GCP for Microsoft. But there's also other reasons that revolve around the way we do things, how we think about doing things, and the options that GCP in generally provided.
Okay, so maybe as you were discussing like some options and some other things, maybe we can go through and you can maybe dive into a GCP structure, like how you're using it right now. So kind of give a brief overview of what we have here and how did you came up with that?
Okay, so when we were moving, like I said, we had a very distributed solution in terms of what we were using. We had some physical hardware, we had some VMware virtualization, we had a private cloud solution on a platform called OnUp. And then we looked at other platforms in terms of public cloud. So that's Azure, that's AWS, that's obviously GCP as well, which is the one we ended up choosing. And when we went to GCP, we said, okay, we need to not only have a single point of managing everything and one single technology when it comes to building our infrastructure, lower layers of the infrastructure, but we also want to structure it somehow, make sure that it works well and is organized well. So we started looking into what options there are on GCP, and we eventually ended up with a setup like the one on screen. So you've got a number of layers in the GCP setup that you can use. You've got organizations, you've got folders, and you've got projects. Now, based on what's on screen, you can assume that there's only one folder possible. Obviously not. You can create as many hierarchical trees as you want. We just didn't need those. So what we did is we created a single organization, because for Minto that's enough. And then we decided, okay, we've got environments, and we've got plenty of those, and we've got some other extra stuff that's kind of needed by everything else. So we said, okay, first of all, let's divide the environments, and then we'll create folders out of those. And within those specific environment or folders, let's create a single GCP project for every service we've got, either service or responsibility. For example, for infrastructure, it's not really services. A VPN gateway is not a service, but it is a responsibility of the infrastructure that we need to provide. So we created the folders, and what you need to understand is in most cases, when you talk about UAT environments or development environments, they mean one thing. For us, it's not that. We create a specifically designed UAT environment for every team we have, so that they can properly access their own setup without affecting other teams. So again, environment/responsibility means a single folder for a specific environment for a specific team. Obviously, just one production. You can't have a number of those. And within those, we created specific services. Like we've got our order service, or we've got our out service, and all of these need to be created both for production and for every team on UAT, so that they can test their stuff, they have something to integrate with when they're doing changes, and so on and so on and so on. This allows us to create a structure that's completely separate. We can, for example, give specific team members access to projects within their UAT without affecting other UAT environments. It's about privileges as well. It's about building an ecosystem that's self-contained to a point where if something goes wrong, it just goes wrong in that one place. It's just limiting the blast radius if something collapses. And the thing that we needed to work out, is one of the things why we chose GCP, is if we can move on to the next slide, please.
Yeah.
Is how do you actually make all of these projects communicate? Because normally when you do is when you create a project, either in GCP or any other provider, you get your private cloud network. Okay, that's a private network, but for example, when you've got microservices like we do, you need to have these services communicate with each other. And the usual approach is to create either VPC peering or cloud interconnect routing, which is kind of a hassle, or just use public IPs. The first one is, like I said, cumbersome. We didn't want to do that. And using public IPs, that's a security thing. You shouldn't do that if you don't have to. So here again, GCP came to the rescue, and this is one of the reasons why we chose it, is you can create a shared VPC network setup. In the previous slide, I've shown that under infrastructure, there's a project called VPC definitions. The responsibility of that specific project is to define the entire networking setup that Minto uses, and then export those settings to specific projects in other places. This way, we can create an entire Class A non-routable subnet of 10.0.0.0 with the 8-bit mask. All of that is ours. It doesn't really leave us because it's a non-routable network. And then we can create subnetworks for every project/environment we've created. And since we had this capacity, we actually decided, okay, let's then build the addressing scheme in a way that we put extra information into the IP address. So if you look at a specific IP address, you can immediately identify what environment it is, what project it is, and what component it is. And those will remain the same across different projects. For example, the first octet is basically constant. It's a 10, doesn't change. But the second one is environment. So if it's a 10, it's production. If it starts with a 2, it's UAT. And then the second part will tell you which team it is. If it's 21, it's team 1. If it's 22, it's team 2. Then the third octet tells you what project it is. And the fourth one tells you what component it is. If you're looking at this specific example, 10.10 to 110, you know it's a production environment for a project called Product Management Service, and it's a PostgreSQL shard. If you wanted to look for the exact same VM, but on a UAT environment for team 1, you would only need to swap out the second octet, the second 10, replace it with 21, and all of a sudden you know what it is for the other team. So building specific information into the addressing schema helps us maintain consistency and predictability. We know where to look for things and how these things are spread out across the entire infrastructure. And this level of control, when it comes to networking, addressing schemes, this is one of the main reasons why we chose GCP in general, because our way of thinking is a bit different than most people have today. We remove abstraction layers. We don't add them unless we absolutely have to. And we try to go as further down the OSI middle stack as we can. So if we can solve something on layer 3, then we will do it instead of solving it at layer 4, and so on and so on. Low-level access, that's something that's unique to GCP. You can control things you normally wouldn't be able to control in a cloud environment. You could only control those when you control the hardware. GCP opens up those possibilities for us, and we leverage them. We leverage them when we build our infrastructure. We leverage them when we build our code, when we build our applications, when we design how we do migrations, how we do deployment, all of that. We like the fact that we are given extra control. And I know it could be difficult and it can be daunting, and you don't have to do it if you don't want to. It's not like that. It's not that you need to be a perfect expert in everything to handle GCP. But if you really have the understanding, the know-how, and the knowledge, which we do, we can use these options and achieve great things that normally you couldn't. And let's maybe talk a little bit about how we build our infrastructure.
Yeah, definitely. I just wanted to kind of ask that question. And actually, this is like the next slide that maybe can help you to kind of elaborate on that one as well.
Mm-hmm. Excellent. So as you can see, we can basically differentiate our infrastructural setup into 4 distinct phases. We've got image provisioning, infrastructure provisioning, stack provisioning, and application provisioning, and these stages happen at different frequency. But let's first go through them, what they actually are. So we use what's called Google Compute Engine, where you build virtual machines, just like you would in a normal virtualized environment, and you have full control of the machine itself. You control the resources, you control the system that runs it, you control the configuration, the hardware that's attached to it. Like I said, pretty low-level stuff when it comes to cloud computing, but very important for us. But what we don't want to do is we don't want to have to build every single machine completely from scratch every single time. First of all, software versions might change, the operating system kernel version might change, things might go away, the repositories might go away, and so on and so on. So what we do is we take a clean image from the GCP repository, and we use it to pre-build specific functionalities into that machine beforehand. So if we know this is going to be a PostgreSQL shard, we take a clean Linux installation, we run a bunch of stuff that we run on every machine that builds our common environmental setup, like the necessary tools, how your shell works, and so on and so on. And then we install a specific version of PostgreSQL in a very generic fashion. And out of that, we build an image. So now whenever you need a PostgreSQL shard, you won't have to install it again, worry about versions, losing compatibilities, and so on and so on. You will just use a predefined image that we already have. So that's stage one. How often does this happen? Very rarely. This is only done whenever we want to upgrade something or whenever there's a need to create something that we haven't created before. Beforehand, when we started, this happened more often because we kind of didn't know what we needed at that point. So new requirements came in, so we built new images. But now that we've settled on a comfortable set of images that we already have, it's only about upgrading whenever we need to do it. And it's very easy. It's required to be done by an expert. But again, this happens very rarely, so it doesn't really affect development, for example. And then when you've got an image, and by the way, we use Ansible to build those images, so we can recreate them at any point. It's completely automated. But basically, the entire process is completely automated, just using different tools. Then once you have your image, we need to build specific VMs for specific needs. And for that, we use Terraform, and that's the infrastructure provisioning. So like I said at the beginning, we have a number of teams, and every team gets its own UAT, but we're scaling. Okay, a new team comes in. They need their own UAT. That's where infrastructure provisioning comes in. We say, okay, we've got these specific projects for every other team, so let's add those same projects for the new team. Create a folder, attach it to the organization, do the networking stuff. All of that is in Terraform. We build a specific set of VMs within specific projects for the UAT environment, and we use the images we created in the previous step. So we know this project needs a web server, a RabbitMQ server, and a PostgreSQL server. So we'll create 3 VMs in Terraform and use the images created with Ansible in the previous step. And that just gives us the infrastructure with the images. First of all, it's just a clean machine with the image, and the image comes pre-configured with the most generic basic stuff that we got from the first step. Now we need to do stack provisioning. Now what's that? This actually takes a generic, for example, RabbitMQ broker and configures it to work in a specific way for that specific purpose. When we build an image, we don't know what the size of the machine will be. We don't know if it will have 2 cores or 4 cores. We don't know if it will be production or UAT, so different error reporting levels. We don't know what the final IP of that machine will be, so you need to configure your RabbitMQ to listen on specific interfaces. We don't do listen on everything. It's, again, a security thing. They basically, since we've installed everything previously and we just need to reconfigure it, then stack provisioning is very fast. It takes usually per single machine a few seconds, a few dozen seconds at most, and it's completely done. And you only need to do it once after you've built up the machine. So if we destroy the environment and rebuild it for whatever reason, then you have to run stack provisioning again. But under normal circumstances, you only run it at the same time you run infrastructure provisioning. It's just a different tool. It uses Ansible again. So it's run pretty infrequently. And this gives us a specific VM with specific resources, pre-configured for specific needs, but also matching the specificity of what the machine will do in that environment in that case. Excellent. Now we need to actually make it do something. that's where application provisioning comes in. This is like deploying an application, running migrations, building up your data structure, importing data, and so on and so on. This is executed very often because whenever a new version comes in, you just run the application provisioning. So this happens on top of all the other previous steps. This is also very fast because it's just about either deploying your code if you're using PHP, or if you're using something else like we do when we do use Golang or .NET, it's just deploying a binary that was pre-built in a CI pipeline. And when you go through all these steps, you've got a working project, a working service. And all of these allow us to do things that are needed at one specific point in time very quickly without having to worry about all the other things at the same time. That's why there are 4 different stages. You could try do it all in one go, and that's where most people start with, but then it becomes cumbersome. Building up such a server will take, I don't know, a few hours, maybe a day. Why would you want to waste time?
Yeah, definitely. It's just to kind of optimize that, and this approach that you have is I think it's from the expertise that you have been running everything. How long were you running? It was 1.5 years already on GCP.
Yeah, we migrated at the beginning of 2020, and we've been running fully on GCP. We have nothing aside from GCP ever since then. And we've gone through probably the biggest challenge you can face in an e-commerce/marketplace environment, which is called Black Friday. Everyone loves that. And we did that in 2020 already. And this approach, this setup, when it came to quickly scaling up and then quickly scaling down to optimize the cost, it worked really well.
Yeah, that's cool, because I really wanted to kind of ask you a question previously, like what are the technologies? Like, are you using Terraform? But here, I think you can't kind of miss Terraform and this kind of ease of use of this tool to kind of improve and optimize all of the deployment that you have. So it's really
absolutely.
Yeah. So maybe like just to kind of ask here, like because most probably before you went to GCP and before you kind of came up with this kind of approach here, you considered some other cloud providers as well. Like why didn't you went for Azure, for example, or AWS or IBM or some other provider? Because as you said, because one of the reasons were like the licensing costs and everything, but what about the others? Because AWS, for example, is also like similar for GCP, and what was the reason behind that?
A number of things. So the licensing, that's out of the way already. But like I said, GCP offered way more control and way more access when it comes to how you want to build it. It's also easier, funny enough. The panel's better. The Terraform support. Actually, Terraform works with both GCP and AWS and most other providers. You just use different plugins on how to use Terraform, but it works really well with GCP in general. So licensing, level of access and control, which was very much in favor of GCP. This is something that's very important for us. But on top of that, the kind of support you get from GCP when you're working with GCP. I don't mean the platform itself, but the people who run the platform. There's a team in Poland, and we're actually located in Poland. The entire Minto Tech is. It was way easier for us to work with a local support team from GCP where we could just meet face to face. It was actually before COVID when we were discussing this. So the support was amazing, and that on top of everything, it's not really a big thing, but it is a nice cherry on top to have.
Yeah, definitely, and this is what we're trying to do as a partner as well, to always have a hands-on approach with all the customers and help them out throughout all the process of migrating and of coming up with those structures that you just shared. So I think
that makes perfect sense. I mean, if you run with GCP, it's very compliant with standards that you would expect from lower layers of the stack. So if you understand how IP works in general, the TCP IP stack, it will work the same way on GCP as it does with physical hardware. So if you have the expertise, and you probably do, because when you're migrating to GCP, then you're actually migrating from something, and that something had to be built beforehand, so you know how to build it. And if you go to GCP, you can pretty much expect it to work the same way. You can just hire any person who understands how to build infrastructure, and they will get up to speed with GCP very, very quickly. So that's one of the things that's very important, and we love that fact. I know, again, it can be daunting, but don't get me wrong, you don't have to do it if you don't want to. It's just nice to know that the option is there.
The option is there, and also as soon as you're getting to know all those tools, it makes your life a lot more easier. Maybe this kind of the change management or the shift in your head takes a little bit of time, but after that, I suppose it's like something that everybody's looking forward to, kind of run everything smoothly and downscale and upscale everything on the fly.
Mm-hmm.
So maybe about some additional questions, because we're starting to kind of come to an end, and we have some additional questions in regards of how does your DevOps team manage Microsoft on GCP? Are there any kind of big differences in the workloads or operations in comparison to other solutions than GCP?
Okay. First of all, we don't really have a DevOps team. We have an engineering team, which is more like what you expect from a team called site reliance engineering. So the focus is a bit different, but we don't have a designated DevOps team. We only have a team that focuses on general development of standards, technologies, proof of concepts, and R&D, and they also handle the infrastructural setup. But when you're talking about differences in running different solutions, do you mean differences between running Microsoft or open source, or differences between running Microsoft on AWS and Microsoft on GCP?
And yeah, actually the difference between Microsoft running on AWS and GCP was most probably the question here.
Okay. I don't really have that much experience with that, but from what I've seen, and like I said, that's not that much, there isn't any, basically. It's just as easy.
Cool. I also see one more question here, which is like, I don't know what is the actual like kind of idea, but I can assume it's something around what's the plan with your current infrastructure? Are you going to use GCP in future? Are you going to kind of grow your open source part or Microsoft part, or you bring in some other services from GCP itself? I think it's maybe that's the question here.
Okay. So first of all, let's talk about what we have. Like I said, all of this is compute engine. That's the bare part, let's call it that, of what we have with GCP, but that's not all. We also use cloud file store and cloud storage and the entire suite of networking technologies like cloud routers, the VPC sharing thing, that's amazing, cloud firewalls, cloud routing, and so on and so on. Cloud NAT, something you actually need to use if you really want to leverage GCP completely. On top of that, we are right now looking into something very interesting called preemptible VMs in the compute engine. How they work is they are extremely cheap in comparison to other GC resources, but you have to accept the fact that you might be upstaged. So you might receive a signal that will tell you, okay, in 90 seconds, we're going to shut this machine down because we need those resources. Get ready, it's going to go away soon. But the way we actually build our services and our applications is to account for these sort of failures anyway. We don't expect our systems to work correctly. We expect them to fail, and we just build our systems to fail. That's actually a thing, interestingly enough. And so if we can leverage the preemptibles and over the way how we build applications, we should be able to decrease the cost immensely. And that's something we are looking into right now. Obviously, there's some things that can't really go away, like your databases or your queue systems, unless you're clustering and so on and so on. But when it comes to your application code, which is the bulk of the amount of servers you generally have, then if you build your applications correctly and you can leverage the preemptibles, it can bring your costs down very, very quickly. And this is something we are looking into right now. We're also looking into expanding to other GCP services from the perspective of less infrastructure, of more needs that the company has. Stuff like Vertex AI for machine learning and AI options. We're actually building a team right now to explore those specific situations. So if anyone is interested to join such a team with us, let me know. I will gladly talk to you. And we're also looking into moving some of our analytical setup to the GCP BigQuery. That's also something that's on the table currently. As for whether we want to stay with GCP, oh, that's a resounding yes, absolutely. We like the solution. It works really, really well. And we have everything on GCP right now, and we don't see a reason why we'll change that.
Cool, that's cool. I think like the way you can actually significantly optimize the cost with those, how did you call them?
Preemptables.
Preemptables. That's something that everybody is interested if you find out the solution how to actually make it work, even if it's going to collapse on the fly. We have one more kind of question from the audience. I think I forgot to kind of say that those last two questions were actually from the audience already. So here's like one more that I see is like, is it important to change some part of your infrastructure into the microservices if you have Microsoft legacy systems and you want to go to GCP?
No, honestly, no. Basically, if it worked before in a specific setup, then it will work in the new setup as well. You can have microservices, you can have semi-monoliths, or you can have monoliths as well. That's also fine. And you can run those on GCP very, very well. It's just your approach to building the infrastructure will have to differ a little bit, obviously, because you'll have to build fewer VMs with a larger set of resources available if it's a monolith. But you can have any setup you want, and I don't see a reason why it wouldn't work.
Mm-hmm. And maybe to kind of because all the listeners and viewers here are most probably are considering for shifting to GCP or considering to start using it from the scratch and everything. And maybe you can just cover like if there are like some other kind of companies or people who are here today that are maybe interested how and where to start if their company wants to go to GCP with already existing Microsoft environment, because you're always in the shadow. You don't know which is the kind of the first step to take to kind of go for it. And maybe you can give some recommendations here, like how did you start with that?
Okay, so the first thing that comes to my mind when you're asking this is you've already made the first step by watching this webinar. But honestly speaking, and to answer your question in a reasonable way, I would say go to the GCP website, create a free account, which you can do. You'll get a bunch of credits for that, and try doing it. Honestly, there's nothing beats actual experience. Move something, a very, very small thing. Choose something small and don't move it on production, obviously. Just try to move it, and trust me, it will work. At which point you'll think to yourself, okay, maybe we can actually do this. It might make sense. Then stop. Go back to the drawing board and think about what is it that you're trying to do at the end. So the structure thing. You don't need to mimic our structure. This structure works for us, and I'm actually very much opposed to the idea of copying someone else's solution, because there is no silver bullet. Every company is different. Everyone's needs are different. So our solution works for us. It might work for you, or it might not. So think what it is that you want to accomplish, but think it through before you actually start moving. And I don't mean the experiments, I mean the actual move of anything. And then go and play with the tools. I mean, I cannot recommend Terraform and Ansible strongly enough. These tools are amazing, and they will make your life easier. They will actually save your life on a few occasions, as it did with us. So do it manually, just play around with it. But when you're moving, don't think, okay, we'll just move a few services, then we'll do the Terraform thing, all the Ansible thing. Start with it. Trust me, because everything you build on top of these tools will be reusable. So if you build it now, all the other 600 services you have to move, they will use that. So it will be faster, it will be quicker. So fail fast, try fast, fail fast, but then go back to the drawing board, think it through, design what you want. Don't expect it will not change. It will, obviously, as everything does. No actual battle plan survives the first contact with the enemy. And we figured this out, what, 2,000-3,000 years ago, something like that. So make a plan, accept it will change, but have one. And then just move. Trust me, it will be way better than you think it will be. Honestly, I will give an example on this. When we were moving, we estimated it would take us about 90 days to move everything, so about a quarter. We moved in 40.
Wow. Yeah, but that's something what you can do actually when you have like an in-house team for and the kind of the knowledge of the VMs and everything beforehand. But some of the companies might not have it, and that's why also we are here as a Revolution partner to kind of cover that as well. So, but I think this approach is like a super good advice to just start from somewhere, play around, and if you feel like there's kind of some blockage or bottleneck, you can always find like a partner, or as you said, like GCP customer support, also together with Revolchi is super useful. And we are like really experts in that field to kind of come up with this structurizing and come up with the kind of the first roadmap, how you can start putting your services one by one as a microservices to the GCP platform. And I think this approach of, just make the first step is just actually something that you can just give an advice for any kind of thing. So I think it's a super good way to make a start.
Honestly, I might have not said this, but don't be afraid to ask questions. So if you need help, reach out to Christian or someone like that who knows what they're doing, and they will definitely help you. And if you have any questions about this meeting after the live session or anything, catch me on LinkedIn. Send me your questions. I will definitely answer. I actually like answering questions. So, like I said, there's a community of people who are working on this, and they are all very open, and they will all help you, myself included.
Yeah, and it's not so scary. I mean, there's like lots of definitions and things you might not know beforehand, but we are here to cover. And I'm really happy that we have Piotr here today, and who's also like really open to kind of go through all the questions. We can have like a different panel for that. And also, if you have any other question, feel free to kind of shoot them on the links on the area below, and also on the right side, so we can just catch up later as well. And thank you for watching, everyone. We're looking forward to kind of get in contact with all of you. And yeah, have a great day meanwhile. And yeah, let's catch up really, really soon then.
Thank you, everyone. Have a great day.
Yeah, thank you. Bye.
Bye-bye.